Welcome, my friends. In this video, we will be introducing statistics and discussing some key statistical terminology. First of all, what is statistics anyway? Statistics is the study of how to gather, organize, analyze, and interpret data, and can be broken up into two broad categories. First, we have descriptive statistics, which deals with organizing and summarizing data. This includes things like charts and graphs that help us understand and communicate data, as well as calculating things like averages or variances. The second category is inferential statistics, which is all about drawing conclusions from sample data using statistical wizardry, also known as probability theory. Inferential statistics includes things like confidence intervals and hypothesis testing. The term population has a broad definition in statistics. A population is really just whatever you want to study. A population could be college students, cows, chickens, watermelons, smokers, children, cars, or anything else. But you've got to be specific. If you want to study college students, is your population all college students, or is it just students from a certain college? If you study watermelons, is it all watermelons, or just watermelons grown in a certain geographic region? The researcher determines the population, and the definition of the population can be as broad or narrow as desired, but a broader population, like all college students anywhere, might be harder to study. Once a population is decided, a sample is usually taken from the population, which is just some portion of the population. So why sample? Well, if my population is all 330 million Americans, good luck tracking them all down for a survey. Unless you're the government, that is. By the time you've tracked them all down and asked them your questions, 1 million will probably have died and 1 million more will have been born. No, studying everyone in the population is often really difficult and expensive, so we resort to samples. Thankfully, statistical wizardry, aka probability theory, allows us to make conclusions about a population as long as we have data from a sample that is representative of the population. A representative sample means that the sample has characteristics very similar to the population. We will talk more about ways to obtain samples in a separate video. The data collected from a sample will contain at least one variable, which is just some characteristic or measurement that can be collected from members of the population. Variables come in two flavors. Vanilla. Okay, no, just kidding. Qualitative variables, which are just categories or attributes that aren't numeric, is the first type. Okay, maybe vanilla does work here. Ice cream flavor would indeed be a qualitative variable. Some people call qualitative variables categorical variables. Quantitative variables have to do with numbers, such as counting or measuring something about the population. Quantitative variables come in two forms. First, we have quantitative discrete variables, which can only take on a finite number of values within some range, typically but not always equal to the whole numbers, such as 0, 1, 2, 3, etc. Frequently, discrete variables are counts, such as the number of dogs owned. As far as I know, you can't own half a dog, so the number of dogs owned is restricted to the whole numbers, 0, 1, 2, 3, etc., and is therefore discrete. Next, we have quantitative continuous variables, which can take on an infinite number of values within some range. Infinity? Is this some sort of statistical wizardry, Luke, you might ask? No, this is real life. Think about your weight. Oh gosh, no, I didn't mean it like that. Okay, think about your height. How tall are you? Let's say you are 5 foot 7 inches. But could you really be exactly 5 foot 7 inches? Most likely that's just rounding. You could maybe be 5 foot 7.3 inches, or 5 foot 7.35 inches, or 5 foot 7.3591023967103918392648 inches tall. Do you see my point? There are an infinite number of possible heights if we just continue to measure more precisely. Sure, you might have to be a crazy person to measure with that precision, and it might not even be possible. But nevertheless, some variables are continuous, meaning that they really can take on any value within some range. Now, I say within some range because I don't think anyone is 100 feet tall, yet. But there can still be restrictions, so I think you see my point. Let's take a look at some examples of variables to see if you can classify them as either qualitative, quantitative discrete, or quantitative continuous. Pause the video and see if you can classify these 5 examples, and I'll be back in just a moment to discuss the answers. First, we have the number of students in a statistics class. This is a quantitative discrete variable. You can't have half a student. We are restricted to only the whole numbers as options, like 30, 31, 32, etc. Hair color is a qualitative variable. It describes an attribute of a person that is not numerical. Miles driven is a quantitative continuous variable. You could drive 10 miles, or 10.5 miles, or 10.212346. You get the idea. Continuous. The amount of money in someone's bank account in dollars and cents is quantitative discrete. But Luke, my students might cry, the money in your bank account can use decimals, so it can't be discrete. You could have $1.23 in your bank account. Wouldn't that be continuous? First of all, before you start giving me handouts, I'll let you know that I have way more than $1.23 in my bank account, just an FYI. Secondly, discrete numbers can sometimes have decimals. They just need to be restricted in some way so we don't have an infinite number of possible numbers between two values. In this case, $1.23 or 1.23 is as far as we can go. You can't have $1.23.7 or $1.23.1239469. You get the idea. There is a cutoff at the second decimal, meaning that money is not continuous. It's discrete. Alright, next, the amount of time until this video is over in seconds is possibly too long to wait for some of you, but it's also a quantitative continuous variable. Seconds can be measured to continuous precision, such as 65.2341 seconds. Once we have gathered data related to our variable or variables of interest, we can calculate numerical descriptions of the data. A statistic is a number that describes some aspect of the sample. A parameter is a number that describes some aspect of the population. Just think sample statistic and population parameter. Can you say that 5 times fast? You bet I can. Sample statistic, population parameter, sample statistic, population parameter, sample statistic, population parameter, sample statistic, population parameter, sample statistic, population parameter. Now, I'm going to introduce a few important examples of statistics and parameters. We won't use them until future videos, but they will come back again and again when you study statistics. You don't need to understand how to calculate these things right now, or even exactly what they mean. This is just a preview of the most common numerical measurements we'll be using throughout this statistics course. Alright, the first measurement, the mean, is a measure of the center of the data, known to the common folk as the average. The sample statistic for the mean is x bar, just an x with a bar on the top, and the population parameter for the mean is the Greek letter mu, which looks like a U with a little added tail on the left. The standard deviation is a measure of the spread of data, which we will talk much more about in future videos. The sample statistic for the standard deviation is S, and the population parameter for the standard deviation is represented by the Greek letter sigma, which looks like an O with a little hat. Next up is the proportion, which is a percentage of some total, such as the percentage of coin flips that come up heads. The sample statistic for proportions is p hat, or p prime, and the population parameter is just p. P hat and p prime mean the exact same thing, and which one you will use will depend on your teacher, but I prefer p hat. These symbols will come back so many times to haunt you throughout your statistics course, so it's a good idea to get familiar with them now so they aren't so scary. I would write down this table in your notes so you have it for reference later when we start to use these symbols more frequently. Alright, let's look at an example to explore what we've talked about so far. Let's say that I teach piano lessons, and I'm a superstar. So I have plenty of students who always want to take lessons from me. I asked 10 of my students how many minutes they practiced last week. I would like to estimate the mean practice time for all of my piano students. Can you identify the population, the sample, the variable type, either qualitative, quantitative discrete, or quantitative continuous, the statistic, and the parameter? Pause the video and think about your answers, and I'll be back in a moment to discuss. Welcome back. Let's see how you did. The population is all of my piano students. It isn't all piano students in general, as my sample only included students that were taking lessons from me. The sample is the 10 students that I selected to ask about their practice time. The variable is the number of minutes practiced last week. The variable type is quantitative continuous. The number of minutes a student practiced in a week can be numbers like 125.92691. Although who is keeping track of their practice time that closely, really? The statistic is the mean practice time, x bar, from the students in my sample of size 10, which hopefully is representative of all of my piano students. The parameter is the mean amount of practice time, mu, for all of my piano students, not just the ones in my sample. Alright, my friends, we have finished our brief but hopefully informative introduction to statistics. We will be exploring many more fun and exciting statistical topics that you won't want to miss, so make sure you subscribe for more videos. No, really, statistics is fun and exciting. You don't think so? I guess you just haven't watched enough videos. Come back, please!